Hi and welcome. Today we're going to talk about transformations. This is day 2. There is a day 1 video on my YouTube channel, so make sure to check that out if you need a little bit of refresher or you're not quite ready for the day 2. We're going to talk about vertex form today, and here are our notes. So I want to let you know that today we're really focusing on a formula. Here's our formula. This is called the vertex form. And our vertex is negative h. Now let's talk about what that means. Negative h means that whatever the number of h is, the sign will be opposite of whatever it is. So if right here it said like negative 3, then that means that my vertex would be positive 3 something. Okay? So now, here we go. So continuing on, my k is also a part of this. My k is going to be the second number in my ordered pair. K is always listed at the end. It's a number all by itself. It will not have a variable attached. It's called a constant. So my vertex is going to be negative hk. We're going to get started on number 1. We're going to talk about if we are given an equation, how does the equation change depending on what numbers we have. So right here, I want to look at number 1. On number 1, I have y equals the quantity x minus 5 squared plus 1. Okay, so that means that our regular graph is y equals x squared. That's called our parent function. Parent function. Our parent function is just a normal graph, and by the way, it's got a vertex of 0, 0, and it looks like that. So that's our parent function. But that equation is y equals x squared. So if I were to change some things around and add, in parentheses, a negative 5, and then put a plus 1 at the end, that means that my equation would, my parabola here that I have, this parabola would be shifted 5 to the right because my vertex is positive 5, positive 1. There's where the positive 5 comes in. The 1 stays the sign that it is. 5 to the right and 1 up. All right, let's look at number 2. On number 2, I've got in parentheses a positive 2, and then on the outside I have a negative 7. So that means that my vertex is going to be negative 2, remember the signs are different, and negative 7. So how is this going to shift? It is going to shift 2 to the left and 7 down. 2 to the left and 7 down. So here's my parent function. Once again, has 0, 0 as my vertex. So if I were going to go 2 to the left and 7 down, then my graph would end up being somewhere probably around here. Okay? So that would be my new graph. Let's move on. Number 3. Determine how the following graphs are shifted from the y equals x squared. All right, well here we got it. A positive 3 in parentheses, which means my vertex is going to be a negative 3. Remember, the signs are different. When it's in parentheses, you change the sign, and a negative 1. So that means that I'm going to go 3 to the left and 1 down. Three to the left, 1 down. Awesome. Great job. All right, number 4 and 5 and 6. Let's keep going. On number 4, how is my graph going to change? Well, what's going to happen is my vertex is going to be a positive 8 and a positive 3, which means 8 right and 3 up. Go ahead and fit that in wherever you can. Okay, number 5. There is nothing in parentheses, so that means that it is not going to go left or right. So I'm going to put 0. Let me make that look more like a 0. 0. Left or right. But then 5 up. My vertex is going to be 0, 5. All right, and lastly on number 6, there is a number in parentheses, but there's no number here. It's like a +0. So that means that I'm going to go, first let's talk about our vertex, positive 7, and then 0. So I'm going to go 7 to the right, and I'm going to go 0 up or down. Sorry if that's hard to see. Okay. So in examples 1 through 6, we just talked about how it would change. We just looked at the equation. We didn't actually graph. So we looked at the equations on 1 through 6, and we thought, how is it going to move? Up, down, left, right, what's going to happen? So now we're actually going to get into the graphing. There's a couple of things that we need to identify for each problem. The vertex, the axis of symmetry, if it's a max or a min, I'll just put M, and then we can put max or min. What's the domain, and what's the range? Okay, let's start. So the vertex, just by looking at the equation, remember it's negative HK. So that means that it's going to be positive 5, positive 1. That's my vertex. You're going to have to make an equation, not an equation. You're going to have to make a graph for each of these. So the first thing that I want you to do is actually draw on your paper your y-axis and your x-axis. And let's draw a vertex, 5, 1. 5 to the right. 1, 2, 3, 4, 5, and up 1. Right there. Okay. So you're just going to make a normal shape with that being your vertex, and I didn't even quite hit it. Let's make sure that I actually hit it. There we go. That's a little bit better. Okay. My axis of symmetry. Axis of symmetry is the line that runs straight down the middle that cuts your parabola in half. So I'm going to make a dotted line straight down the middle all the way down. My axis of symmetry is 5. Your axis of symmetry is always the x value of your vertex. Maximum or minimum? Okay, the difference. Maximum means that my parabola tops out, that it can't go any higher than a certain number. That would be a downward facing parabola if it were a maximum. If it's a minimum, it means that my parabola basically bottoms out. There's a bottom, then end to the parabola that's a low point, and nothing, no lines, no points can be under. So right now, this here is the bottom of my parabola. That's going to be a minimum. My domain means on all the x values. Please notice how my parabola is just going to extend forever and ever to the left and forever and ever to the right. Basically what that means is that my parabola is going to go to the left infinite numbers. It'll go on to the negative. It'll go on to the negative hundreds, thousands. And it'll go to the right. It'll go to the right as high as we can count, higher than we can count, to infinity. So my domain is actually going to be, I'm going to say it's infinity. Now, infinity means higher than you can count, lower than you can count, infinity. So it's going to be negative infinity. This is how we write it. Our parabola, our x, is going to be all the way to negative infinity, and it's going to be all the way to positive infinity. This is actually pretty hard to write on the screen. So, there's my negative sign for negative infinity. The x in the middle means x is in between negative infinity because my parabola goes forever. Once again, the blue goes forever to the left. It's just going to get wider and wider and wider and wider the higher you go. And forever to the right, higher and higher. So that's domain. The domain's actually going to be the same for every parabola that we're going to do today on our lesson. All of our parabolas will be upward facing. And the range. Now let's talk about the range. The range means on the y-axis. Here's my y-axis, remember? On my y-axis, what is that point basically that it bottoms out at? Remember, it's right here. This 1 is where my parabola bottoms out at. So it's going to say that my range is going to be y is greater than or equal to 1. So we need to make sure that we do all 5 of these things for each problem. All right, number 2. On number 2, let's first figure out, we've got vertex, axis of symmetry, minimum or maximum, domain, and range. Okay? So our vertex is going to be, look at what's in parentheses, the opposite sign of what you see. So it's going to be a negative 2, and it's going to be a negative 7. My vertex is going to be negative 2, comma, negative 7. Now let's graph that. Something I want to talk to you about. If I need to make a graph of negative 2, negative 7, and my x-axis and y-axis are not drawn yet, I need to really pay attention to how I draw my graph. I can't just go down the middle and down the middle for x and y. I need to be able to get down to negative 7. So here's what I'm going to do. I'm going to actually make my y-axis normal, nothing different. But what I'm going to do for my x-axis is I'm going to raise it up a little bit so that I can actually get down to negative 7. So let's draw that. Plot the point. Negative 2, negative 7. Okay, there we go. So, my dot, there we go. That's a little better. Okay, there's my vertex. Let's draw a parabola. Remember, right now it does not, we're not worried, just a basic parabola, how skinny or fat it is. Axis of symmetry goes right down the middle. It's at negative 2. Always the x-coordinate of your vertex. This graph bottoms out. It has a low, low point of negative 7, so it's going to be a minimum. So I'm going to write minimum. And then my domain is going to be the same thing, infinity, with x in the middle. So I'm going to make a compound inequality. A compound inequality means that I have 2 inequalities in one. 2 inequality symbols with a variable in the middle. So I'm going to write negative infinity is less than or equal to x is less than or equal to positive infinity. And my range is going to be, where does my graph bottom out? Okay, so any number negative 7 and up my parabola will hit on the y. My range is always y, the y values. So my range for number 2 is going to be y is greater than or equal to -7. And that's number 2. Good job. All right, so now we're on number 3. We can move a little bit faster. And again, please press pause anytime you need to stop. You need to go back. You need to check something. Here we go. Vertex, axis of symmetry, minimum or maximum, domain, range. All right, vertex first. Look at your parentheses. It's the opposite sign of that. -3, -1. All right, good. So I can actually draw my graph pretty normal. So let's make my y-axis standard, my x-axis standard, and let's plot it. Let's plot our vertex at -3, -1. 3 to the left, down 1. All right, there it is. So, axis of well, let's draw a basic parabola. All right, perfect. Axis of symmetry now goes right down the middle. Right down the middle. My axis of symmetry is -3. Axis of symmetry is always the x-coordinate of the vertex. My graph bottoms out. My graph bottoms out, so that means that it's a minimum. Let's just do the range while we're at it. Look, it bottoms out at -1. All values above -1 will be in my y coordinate at some point. You know, if my graph kept going on and on forever up, it would get wider and wider and wider, my parabola would. So that means that it would be, you know, it would hit -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So anything higher than -1. Y has to be greater than or equal to -1. And you guessed it, the domain's going to be exactly the same as we've been doing. Let me do my best here. -infinity to +infinity. Forever to the left, negative numbers, -infinity. Forever to the right, positive numbers, +infinity. Okay, number 4. Vertex, axis of symmetry, minimum or maximum, domain, and range. My vertex, look here. This should be easy for you at this point. +8, +3. Axis of symmetry is going to be 8. Let's draw a little graph. Okay, we're at the same problem that we had before on number 2. I got to get to 8 on my graph. So that means that I really need to pay close attention to how I make my x-axis and my y-axis. I'm going to make my y-axis pretty far over here to the left because I need to get 8 over. And I'm going to make my x-axis just kind of normal, nothing special. So go ahead and draw your axes. Now let's plot my vertex. 8, 3. Over 8, up 3. Perfect. Now, axis of symmetry means that well, let's draw it first, huh? Axis of symmetry is going to go right down the middle. Boop, 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 boop. Okay. Axis of symmetry is going to be 8. This bottoms out right here at this red line at 3. So it's a minimum. My range is going to be any number greater than or equal to 3. And the domain, you guessed it, the exact same thing we've been doing before. -infinity is less than or equal to x, is less than or equal to positive infinity. My parabola will go forever to the right and forever to the left because the higher it goes, the wider the parabola grows. Did you catch that rhyme? Hope you did. All right, for number 5, I want to have you try and do a lot of it on your own. I also want you to work with a partner, or if you're sitting at home, on your own, you got to work on your own. But if you're in class right now, I want you to turn to someone in your group and work on number 5. And I'm going to pause the video. So go ahead and pause the video now. And the answer will come up in about 5 seconds. All right, here are your answers. Check your work. Check everything here on the left. Make sure that it all looks good. Number 6, same process. One thing that I want to add before you start number 6 is that this is basically like a plus 0 at the end. There's nothing there, so that means that your k, your y value, is going to be 0. So go ahead, press pause on the video, and do your best to fill in everything you're going to need, just like 1 through 5. Okay, here's your answer to number 6. Check your work, make sure everything looks the same. Awesome. The very last thing is for you to just practice on your own. If I gave you a graph, could you write the equation? One thing that you need to remember is that here is the format that your equation needs to be in. Y equals. Write this at the top of your paper. You're going to need it. X minus H squared plus K. Sorry about that. Plus K. I wrote a little bit too big. This is a minus sign. X minus H squared plus K. All right? Write it somewhere on your paper so that you don't have to keep turning to the front page. All right? Get going. Good job. See you again.